Today we're going to be talking about monitoring. And in specific, over the next 55 minutes here, my goal is to talk a bit about sort of what is monitoring and why do we monitor. We're starting at sort of a base level to understand, like taking a step back, why do we do this? Which is probably obvious, but I think is worth taking a moment for it. How do we monitor well? What are some things we can do and be successful at? And what are some ways in which we can not be successful? What are some good things and bad things? Also, just so you have an idea of sort of what the basic level of the talk is, this is a very broad overview. We're going to talk about small companies going up to large companies, a lot of the inflection points you face in monitoring and how it transitions from 10 servers up to tens of thousands of servers, some of the mental shifts you have to make, as well as some of the ways to approach it. So we're not going to dive a lot into tooling here because every company does things differently. We will talk a little bit about some tools just to give you a baseline, but this is also not a Dropbox-specific talk. A lot of these are things that we do, a lot of things are things we don't do, and hopefully we'll start doing at some point. So who am I? Again, my name is Mark Smith. There's my email address if you need it. I'm an SRE at Dropbox, been there for about 9 months now. Previously at a small company called Bump, also Mozilla, Google. Been doing this since 2004 at a company called LiveJournal, which became 6 apart. Whole fun story there. One really important thing you should know about me, and is relevant to the rest of this talk, is I don't really like to get paged. I don't like waking up at 2 a.m. I've been doing this for 10 years, carried a pager for most of those years, and it's really not my idea of a good time. So if you come out of this talk and you learn a couple of things about maybe reducing how much you get paged, or ways to think about it so you can fix your systems or make them better, then that would be great, and that's one of my goals here. So before I dive too far into here, I'm going to do a quick poll. Are you a manager? If you can put your hands up, if you manage a team of engineers or SREs? OK, awesome. Thank you for coming. I'm very happy to have management involved in these discussions. Are you a software engineer? Not SRE, but you specifically identify as a software engineer. Perfect. There's a couple of you. Also, thanks for coming. I hope it's not too weird. Are you an SRE? All right. There's going to be the bulk of you. Thank you for coming. And if you identify as some of the role, thank you also for coming. So when I say server monitoring, or when you think of monitoring, what do you think of? I polled the internet, a reputable source, and came up with a whole bunch of different sort of things that people think of when you think of monitoring. It's hard to tell, but the bottom right is just a console. And pretty much that's what I've been doing for 10 years. It hasn't changed too much. Spent a lot of time looking at shells. So I posit, I would suggest that monitoring well is the ability to answer two very simple questions. You want to be able to answer what is wrong and how wrong is it? Because just knowing something is wrong doesn't really tell you much. You need to know if this is a hair on fire incident or if this is okay, I'm just going to worry about the tomorrow incident. These are very important. So again, this is a Dropbox agnostic talk. And this is actually going to be kind of agnostic to anywhere I've worked. It's sort of an assembly of a bunch of different things I've seen over the years. So we're going to talk about mywebsite.com. This is a real website. They sell websites. But it's easy to say. So the whole story is made up, though. So it's the beginning. You are the technical half or one of the technical people, or you're launching a business, something like that. And in the beginning, there's a couple of users. You probably know them all, and they're your family and your friends, or your college mates, et cetera. And your monitoring system is the CEO, or whoever the business side of the equation is. While you're writing code and doing things, they're refreshing the site, seeing if it works. This actually works for a little while. Like, you don't need anything fancy if you have this kind of service. But eventually, CEO as a service doesn't really scale. They like to think they do. And they will continue to page you for many years, long after yes, we heard about that 10 minutes ago from our monitoring system. So it takes a while. So let's take a step back here. What do we care about? What is it that SREs, operations, whatever you want to call yourselves, what are we trying to do here? We have 3 jobs, basically, or 3 things that we care about, sort of the pillars of, if we accomplish these, then I think that we're succeeding. And the first one is the service should be up. If you were at the keynote this morning, you heard Ben Traynor talk about Gmail 2010 and Gmail 500. That's the same idea, right? First and foremost, we care that our service is up and running. We care that our service is correct. It's all well and good to be up, but if you're just serving 404s, you're not really doing anything. So correctness is sort of another tenet of this. And thirdly, and I think just as importantly, your service should be secure. And this is something that is easily forgotten as we build our monitoring systems, but whether or not people have access to your systems, if your data is secure, et cetera, is really important. So when I say upness, what do I mean? Briefly, is it reachable? Can someone perform queries? Doesn't matter if those queries are correct or not, but can they perform them? Do all of the components of your system return responses? Does everything seem to be working well? Latency monitoring is also here. You can define upness as 300 milliseconds, 200, whatever you want to define as your metric, your SLA. That's your up definition. Correctness is the idea of, is it returning what you expect it to return? Is it throwing 500s, or if you're a web service? If you're not a web service, like Dropbox has a lot of internal things that are not really web services, and we have a lot of different types of correctness measurements for data integrity, things like that. Security-ness is just the idea of bad actors. Like, is your site under attack? You should probably know if somebody is actually probing your site. Did somebody get access to your Bastion box? Is somebody looking at your database or your data? Does somebody have your S3 keys? Like, are you using CloudTrail to monitor who's using your accounts, what IP addresses they're coming from, et cetera? It's very important. At a small organization, you'll probably be doing this yourself. As you grow larger, you'll develop a security team who will typically take on a lot of these responsibilities. So this is my baseline assumption. This is what I think SREs should care about: being up, our service being up, service being correct, service being secure. So how do we do that? How do we make this go? So this is our job. Let's say you've got this job, and how do we do it? Well, we're starting with this mywebsite.com. It's still pretty tiny. We've got this handful of users. That's great. Broadly speaking, the first thing most people do is they find Nagios. They go to the internet, and either they've heard about this from somebody, or they search for, how do I monitor my server? And they find Nagios. I might knock on Nagios a little bit. It's been one of those things that I love to hate over the last 10 years. Like, it was released, 20 years ago, hasn't changed in 10 years. It still works. Like, we use it at Dropbox. I've used it pretty much everywhere I've been. But I will knock on it a bit. If you're not familiar with Nagios, effectively it's a check-based system where you tell it, here's a check to run. Here are some parameters. So for example, you can say, check HTTP, here's the URL, go connect to it, see if you get a 200. And then it returns, yes or no. This lets you sort of get paged if something breaks, if something goes down. But it's very binary. It's very, yes, this is working, or no, it's not. It has no concept, very little concept of time, or any other fancy things you might want to know. But at the very beginning, this is basically all you need. You have a website, you want to make sure it works. And again, this is going to be sort of skewed a lot towards websites. I know we have a lot of website companies here. But these ideas should be applicable to other organizations or other types of services as well. So, okay, you start out with this very simple system. It can run some checks for you. They come back critical, okay, et cetera. But how do we make an effective check? What are some things that we can do to make sure that the things that we check are actually worth checking? The primary rule here, if you page someone, if you have an alert, if you have a check, it should be actionable. So, for example, foo.com, which actually should be mywebsite.com, is not resolving. That's probably something you care about. Maybe your DNS is down, or there's a routing issue, or whatever else could be the issue here. You probably care that people can't resolve your domain name. On the other hand, Web23 has a load average over 30. Some people like to page on load average. I've done it in the past, and it's never actually led me anywhere well. Sometimes it finds a problem, but there's probably better things I could have monitored that found the problem to begin with. So I will reiterate, the golden rule of monitoring: if it pages, there should be shit to do. Excuse me. There should be stuff that you need to do. Don't wake somebody up at 2 a.m. If it's just like, oh, by the way, you lost a web server. I know you got 30. One died. You don't care, but happy 2 a.m. Like, no. So great. You have your Nagios-based check system. You're going to put some checks into it. What kinds of things, like how does this work? And the first thing you generally start with is what are called black box checks. It's the idea of you want to abstract away all of the systems that lie underneath, and you just want to say, does it work? This is the idea of just answering the question, is my website up? Can people search? You're not thinking about anything underneath. You're just making sure that things are working. So These are perfect for dashboards and status pages. You're going to want people to, like, your company grows a little bit. You get somebody who handles, customer support. They want to know, is stuff up? They're going to want to look at these kinds of checks, which answer that question very quickly. If you want to expose this to your customers, so they have a status page, like Amazon status page, anybody who provides a status page, they don't tell you how their service works. They just tell you if it's working. That's the idea of a black box check. And you can check many things using this kind of system agnostic thing. The problem with black box checks is that they are trailing indicators of trouble. Broadly speaking, a check that says, is my website up or not, will fire when your website is already down. So you're now behind the curve. Like, something has happened. You didn't know about it before it happened. Now your site's broken. Now you get paged. Well, you get paged 4 minutes later, 5 minutes later, depending on your Nagios retry intervals, et cetera. And then you go deal with it. So, okay. But if you're mywebsite.com at this point, you've got maybe 20 servers, a couple of employees, a couple thousand customers. You just crossed an order of magnitude, so that's great. This is probably all you need. You can spend your time building features, building out other stuff. You don't have to build crazy in-depth monitoring systems that are perfect when you're at that scale. And, so don't. So for black box checks, okay, we're going to deploy a bunch of those, but what kinds of things should you check? What should your goal be with building out your checks? In particular, I have this, I don't know if this phrase is used anywhere else, but it's this idea of umbrella checks. It's a small set of 5 to 7 things that if those things are green, you have a 99% certainty that your service is working. This is like, we're getting traffic. We're not delivering 500s. The database is up. Things like that. That if any of those fire, your site's down. Something is wrong, and you should deal with it. This is these are the checks that your company will probably go on, for many years, hopefully. It will grow and change. But at the end of the day, you will still have these 5 checks that everybody will come back to and say, are we working? Are we serving queries? Are ads being served? What's our 500 rate? Things like that. So I went ahead of my slides. Apologies. But for mywebsite.com, we're going to pretend that we're adding a homepage check that makes sure that our page returns a 200, a latency check that makes sure that the homepage returns in less than 3 seconds, because that sounds good. It's actually terrible, but it sounds good. An error rate, which if you're doing this sort of like black box check, you're probably just doing like a tail dash 1000 on your Apache logs and grepping for 500, grepping for 200, and doing some division, and then seeing if it's above some number. Like, it works. And at the beginning, right? At the beginning of any service, like, your goal is to get what works. Your goal is to get to the 2 nines of monitoring. You're not optimizing for that last bit. So now you probably want a dashboard. Just install Ganglia or Munin or whatever your sort of choice is. You drop it in, you run it on all your servers, you get graphs. You get CPU graphs, swap graphs, all those sorts of things. You don't have to think about it too much. In specific, though, you probably want to extend your early dashboard to have your umbrella checks. You want to be able to go to a page and see, with as much detail as you can, okay, what is our QPS rate? What is our error rate? What is our latency? Whatever numbers you can get will help you when you do get paged, diagnosing what is going on. Specifically, though, like at this early stage, this dashboard and sort of the checks are optimized for knowing that there is a problem, not what the problem is, though. There's not enough. With a system like this, it's really hard to get enough data to accurately pinpoint problems reliably. So you may not want to try. So handling problems. You will have problems. Your site will go down. That's, I think, why all of us are here, why we have an industry of this, because computers are unreliable, code people write is unreliable, people are unreliable. We have to figure out ways of making reliable systems out of unreliable components, which is an interesting challenge. One thing I want to touch on here is, so I'm actually a pilot in my spare time, small aircraft, single engine. And one thing that they say in general aviation is this idea of aviate, navigate, communicate. And it's the idea that, so you're up there flying around. You're in an airplane, you're over the hills, San Francisco, sightseeing. Your first responsibility is to fly that airplane safely. Nothing else matters. At the end of the day, if you are keeping the airplane in the air, pointing it in a direction that's safe, you're not going to run into anything, you're not running out of gas, you're not, crashing or anything like that, then you're fine. Everything else is gravy. So prioritize. The second part is navigation. Okay, you're flying safely. Your airplane's up in the air, it's staying up in the air, it's aloft. Everybody's happy. Where are you? Where are you going? This is strictly less important than, am I getting there safely? And lastly is communication. Great, your airplane's safe, you know where it is and where it's going. Now you can talk to people. But they teach you, like, when you get up there in a cockpit and you're flying around, like, ATC can be yammering at you. But if you're landing or something like that, ignore them. It doesn't matter. It doesn't matter if the government's saying, like, you need to do this or that. Like, you're landing an airplane. You can focus on that. So black box checks are sort of the first step here. These umbrella checks tell you if your sight's up or not with a reasonable degree of certainty. This gets you the first half. This gets you the idea that, if these fire, something is wrong. You should fix it. But they don't really get you the rest. They're just focused on, is your site running or not? And this is great. The next iteration, though, the next thing we want to do as your site grows is you want to get ahead of the curve. You want to start being able to say, okay, instead of we had 5 outages this week, that was great. We reduced our time to response, our time to recovery by 40%. Instead, you want to be able to start saying, we noticed that this was going to become a problem, and we fixed it before there was an outage. So how do we do that? We start talking about metrics. We start talking about internal services. So my website.com here probably is made up of web servers, load balancers, caching servers, databases, whatever you want to call it. There's probably switches involved. If you're in the cloud, it gets a little different. I've mostly dealt with physical hardware in my career. Dropbox is kind of half and half, so that's new and interesting. But at the end of the day, you have services and they have internal metrics, probably. If they don't, you should make your developers give you metrics. All services should publish metrics. Everything. What is their latency, their request input, their request handle rate, their error rate? Like, even if it's just 5 metrics, and even if you have to push them really hard, you need them. If you're going to be able to build reliable systems, you have to be able to predict failure and understand load characteristics, which means you need metrics. So, white box checks. We talked about black box, which is sort of the holistic. It doesn't know what's inside. It just checks if the system works. A white box checks is the idea of understanding the system internals. This is when your developers are deploying a new system or you're deploying a new system and you build out these metrics, you start thinking, okay, these are the checks that I'm going to write against these systems. I'm going to have a latency. On my backend database, I'm going to monitor query latency. That's a white box check. It's part of the backend, part of the internal system. The important thing about these, though, is that these can be leading indicators. Once you've got your system and you understand what the data looks like, you can start saying, okay, if my latency on my, let's go down to the caching layer. If my memcache hit rate falls below 89%, I'm going to start seeing latency on the front end. Web requests are going to start slowing down. If web requests start slowing down, we start chewing up Apache workers. If Apache workers chew up, requests start piling up, latency goes through the roof, site crashes. And you could have known an hour ahead of time, or 2 hours or whatever, if you were monitoring that internal memcache hit rate. So white box checks are generally things that are hard to expose on dashboards and such, to some degree, because they're mostly useful to the engineers who know the system. If you just send somebody a link to a dashboard, and it has, oh, here's a memcache hit rate, unless they actually know what that does and what part of your system is, they're going to say, this is a cool graph. Why did it dip here? Why is it doing this? And it's like, so again, though, if we're talking about checks and we're talking about paging and we're talking about monitoring, remember the first rule or the golden rule. Like, you might think, oh, it's great. I'm going to throw 30 checks on this thing. It's going to be monitored to death. And then you're going to get paged over and over and over. And you're not going to know actually what to do with this information. You don't know where the thresholds are. So for our example, my website.com here, we're going to just monitor, just as an example, memcache hit rate and async job queue depth. Because both of these, like, if your hit rate wobbles, like, it's probably going to be fairly stable. If it deviates by more than a couple %, there's probably an issue. Also, async job queues tend to be things people forget to monitor. And then they wonder why their emails are delayed by 6 hours, which they don't find out about until somebody, like, requests a password reset and doesn't get it. So this gives us the navigate piece. Black box checks give us aviation, or the first part. Like, are we working? Is it going? These don't replace that. You don't get to say, we're not going to monitor if the website works anymore. You don't throw away your umbrella checks. Because at the end of the day, these are really hard to tune. These are really easy to screw up or to have thresholds that don't help you. If it's too loose, then you don't get notified when there's a problem. If it's too tight, you get paged all the time. Black box checks are a lot more reliable. If they fire, there's probably a problem. You may not know what it is, but there's a problem. So this is great. We're adding a lot of checks. We're filling out our Nagios with a whole bunch of things. It's doing a lot of stuff. Then you have a shift, and you don't get paged for 3 days. And you start to wonder, either you're done, you've solved everything, you're going to get promoted, and you're happy, or maybe there's a problem. So one of the next things you want to do, and I'm putting these in an order because of my slides, I have to put them in an order. You can do this earlier, that's fine, but you should have monitoring. At Bump, we call this the watcher, and we had a completely external service that basically shared nothing with our existing system. It used an entirely separate notification flow, an entirely separate monitoring flow, and it called back into our normal monitoring system and said, you know, Nagios, are you running? And there was this sort of, we monitored the watcher from Nagios, and we monitored Nagios from the watcher. So it was kind of this bidirectional thing. But it gave me the peace of mind that if I had a quiet shift, it wasn't because something was broken. It was because I was having a quiet shift, which happens. So that was great. Unless, of course, your phone's dead, but we'll talk about things for that later. So great. We now have 100% coverage. We have a black box checks, make sure our site's up. We have our white box checks, making sure that all the details work. We have our leading indicators and trailing indicators. We even have our monitoring system. We feel good. So our website grows. We have many alerts. This is great. I've gotten to this state before, and then rapidly progressed into this state, where I've added lots of checks, and they're doing exactly what I told them to do. Problem with computers, they do what you tell them to do. And Nagios is just red all the time. And a lot of the time, there's this irrational exuberance to monitor. There's this tendency to over-monitor, and this comes from fear. Often after outages, something in outage happens. Like, you're like, oh, crap, the site was down for 20 minutes. I have to write a postmortem, do all this stuff, figure it out, what happened, and then you come up with action items. And one of them will be, this is the alert that if we had this alert, we would have known that there was a problem before it became a problem. The next 6 action items are, while we were thinking about alerts, here's some more alerts we could add that could hypothetically be useful to us in the future. So your fear leads to anger, and you decide to monitor that. And monitor everything. And some of you probably see this where this is going, but this leads to hate. Of your job, of Nagios, of everything, of your phone, irrational hatred of AT&T because they keep calling you. Like, PagerDuty, I love the PagerDuty guys. They come over and hang out at our office, and we talk to them and stuff, but I kind of feel bad. It's like, your job is to wake me up at 2 a.m. So how do you deal with this? You start adding lots of checks. Where do you go from here? One of the first things you can do is paging tiers. You say, my website is down. You probably want to know about that, no matter what day it is, no matter what time it is. In the middle of Easter Sunday morning, breakfast with your kids, your service goes down. You might want to know. There are other things you don't, though. You lose a load balancer and it fails over. You probably should deploy another one, but at 3 a.m., maybe you don't care. That may be a bad example. Depends on your situation. But you probably do want to know if it's a reasonable time to be awake. So you page someone kind of in this middle tier. And these are all flexible. I've used these in the past. You can adjust them. Adjust them for your particular situation. But the idea is just think about your alerts and think about the severity and how urgently somebody actually needs to respond to this. Related, there is such a thing as not paging people for alerts. So sanity is precious. Don't waste it. And talking about that, non-paging alerts, there are many alerts that we set up because one time a database ran out of disk space. And we should probably know about that before it happens. And we set the threshold to 70%, and we get paged when the disk gets 70%. And then we look at it and we go, it's not going to fill up for like 2 months. So you schedule downtime, and a week later, you get paged again. And then you schedule downtime, and a week later, you get paged again. This is not a great use of time. Ticketing systems, like I'm actually a proponent of using a ticketing system here. Like if you have these alerts that fire that are not critical, but somebody just needs to look at them and handle them, have them open a ticket. Like don't generate any notification, like no email, no paging, and just have it be part of your on-call that you go check Jira, you go check RT, whatever your tracker, Bugzilla, et cetera is, and you say, there's stuff to do. Just have it be part of sort of the Monday going on call shift. This also saves a lot of sanity of the, oh, I got 7 emails today, looking at them, figuring out which ones are actually important. One common theme you'll get here is, as your system gets more and more complex, it starts to generate more and more email and more notifications. This leads to sort of notification fatigue, which means people stop paying attention, which means error rate increases, which goes against building reliable systems. So related to this, we've added lots and lots of checks. This next sort of meme, normally we wouldn't want to listen to this guy, but in this case, he actually does have a bit of good advice. Be kind of hygienic with your alerts. Don't let cruft accumulate. There's this notification fatigue I mentioned, but there's also sort of the, you get paged at 3 a.m., probably the first 2 things you do are hit the dashboard and hit Nagios, or whatever sort of your alert thing is. Because you want to see what the other alerts that are firing are, because website down doesn't tell you what's broken, but your 7 whitebox checks that say, oh, memcache hit rate dropped to 82% or something like that in the last hour, that's probably what you want to see. But if that's buried in the middle of 400, oh, disk usage on this node is now 82%, you're never going to see them. So you want to clean up alerts. One of the really good ways of doing this is sort of like the idea of tickets, but aggregated alerts. This is actually something that Dropbox does, where we have a lot of alerts that don't page, and they don't email, they never let us know, except once every day at around noon, it bundles them all up and says, and it pages the on-call and says, there are 7 things that need to be dealt with. And they're low priority things, but they're things that need to be dealt with. And it's the on-call's responsibility to go take a look at them and clean them up. So you get basically 1 period in the day where you get paged for this, and you go deal with it. To make this work, though, you have to have group accountability. And this is just sort of like, it has to be built into your culture. We're all in this together. I'm going to hand the pager off to you, you're going to hand the pager off to you, and then you're going to hand the pager back to me. So if I let something slide, it's going to just slide back around to me, and eventually it's never going to get done. Have group accountability, have people be vested in building a better system. So great. We're scaling. Our mywebsite.com is now getting up to about 1,000 machines. Like, it's fantastic. At this point, you really start having to make a mental shift. We've pretty much, aside from the random little 2 instances that for some reason nobody can ever stop being a single point of failure, like everything else is, you've got 45 web servers and 85 databases, you've got automatic slave cloning and promotions and all this sorts of good stuff. And you need to start shifting from thinking about servers to thinking about services, thinking about what you're providing. So we reach a time that I would like to reach in my life, which is sort of the end of Nagios. So you want to start thinking about alerts that are more like, less like my website is down, and more about, is the latency on my website above 300 milliseconds for 10 minutes? If so, page me. You don't get woken up if there's a brief spike of latency. You do get woken up if there's a huge spike of latency. You could combine this with, if latency is over 3,000 milliseconds for 1 minute, then page me. So, but to do this, you have to have sort of data points over time. This is called time series. Probably most of you have worked with this, but if not, as a brief introduction, you want to be able to do more than just say, is it up or is it down? You want to be able to get pretty graphs like this, where it actually has time on the bottom here, and it has a bunch of different layered data points, and it tracks them, and it lets you see, okay, what is this metric for this server? What is it doing? What did it do yesterday? What did it do last week? Nagios can't really tell you that. It can just tell you, well, it's up right now, or it's down right now. You can get some fancy plugins for Nagios that let you do sort of overtime stuff, but like an actual honest-to-goodness time series system is more flexible. So, okay, so you go out and you get OpenTSDB or InfluxDB or Graphite, or one of the other systems that lets you put data in and metrics, and you say, great, now how do I actually use this? First thing you want to do is store everything, really. The value of these systems is directly dependent on how much data is in them. A database, an empty database, is not very useful for anybody. A full database with all the data you want is very nice to have. Generally speaking, you collect a data point on each metric every 15 to 60 seconds. So to explain this, you probably, on all of your machines, you'll collect some data, like CPU usage. You'll have like idle usage, system usage, user usage, I/O usage, nice CPU usage, et cetera. And every 15 seconds, let's say, you put those into the time series. You may not do anything else with them yet, but you've started storing this data. So you have a nice granular view of exactly what this server was doing over the last however long you've been keeping data. Once you start storing all the data, you have to start correlating it, right? These things have a tendency to accumulate thousands of data points or metrics, and it can be really hard to understand what's what. This is sort of the opposite of advice of Nagios, where it's like, be careful about what you check, because it'll wake you up, or could wake you up if you're not careful. Time series, you want to put a lot of data in, and then you want to start looking at it. You want to start saying, okay, we just had a downtime, or our service was just down. What metrics did what? Okay, well this was a memcache outage, so we can actually see here are the 5 metrics from memcache. Oh, this one was the leading indicator. Like you can see, oh, the hit rate dropped before the latency dropped, before this dropped, or before that dropped. But then you can say, okay, when this one drops below this threshold, we will go down. Again, though, remembering about alerts being actionable, good metrics are extremely highly correlated with one of the peers, one of the things that you actually want to know about. So how do you actually alert on time series? You throw a bunch of data in these systems. You want to do something with that data. In essence, using a time series to alert is, whereas the Nagios-based check system, you run a script or you run a check and it does something, and it returns a yes or no. A alert from a time series is more, what are you monitoring? How long do you want to monitor it? And what threshold are you comparing it to? If you remember a couple slides ago, there was the latency for the website, what I'm looking at, over 300 milliseconds, the threshold I'm looking at, for 10 minutes, the time period. This allows you to express some really powerful type of alerts. One thing you will start to find, though, is that if you tighten your thresholds down, if you get annoyed that you missed the site got a little slow this afternoon, so I'm going to lower this, you'll start to find that the site gets slow every afternoon. And maybe you care about that, maybe you don't, but again, we're back to, if you page someone, it should be actionable. If you're going to page at 200 milliseconds, and you hit that every peak, and then you're just going to look at it and go back to work, it's probably not a useful page. So I've been kind of vague about, like, okay, it's pretty easy to understand. Yeah, we're going to put CPU on each machine. That's a very specific component or a very discrete component. But we're talking about latency. Like, how do we actually get that? Do we store every request? Like, at this point, we're talking, we have 1,000 plus servers. We're probably getting a decent number of requests, let's say 1,000 QPS. So our mywebsite.com has about 1,000 QPS, or queries per second, if you're unfamiliar with the abbreviation. But we only put data in the time series every 15 seconds. And we don't want to store every request, because now we're talking about 15,000 things being stored in our database. And really, that's a pretty heavy write workload. To make these monitoring systems, to make time series scale, you have to think about sort of aggregating your data in some way. So we have our 15,000 aggregated samples, and we can calculate percentiles. We can make histograms out of this data, and then submit each percentile as its own. Let me explain what I'm talking about here. This is a latency distribution. Like if you actually plot out, if you can sort of tell, it goes to 0 on the left side, and then it comes up at about 1 second, and then it trails off. And there's this infinitely long tail out to the timeout value. This is a pretty standard distribution you see with computers or with latencies, right? It's mostly towards the beginning, and there's just this really long tail. If you store this in your time series, you can actually do some really interesting things. So why percentiles? In essence, it allows you to ask more precise questions about your data. Like we were just looking at, if latency of our website's above 300 milliseconds, page me. But what does that mean? Does that mean if any request was above 300 milliseconds? Because I guarantee you there's going to be some. It's going to be somebody who has 5,000 friends loading their profile page, which then has to do 5,000 memcache requests, which 4,000 of them are not cached because they're all dead accounts, and so it hits the database 4,000 times, right? Like, that's going to take more than 300 milliseconds. But do you really want to get paged by these outliers? Do you really want to know? Probably not. So looking at this distribution here, if you think about sort of the percentiles, there's 50% of the requests are probably less than a second, or a second or so. But if you look at it sort of like 75%, it's probably around 4 seconds. 95% of the requests are less than 9 seconds. And 99% are less than like way out there. Storing these sort of individual percentiles lets you ask more precise questions. So for example, you can say, I want to look at the 50th percentile of my latency, which means half my requests completed faster than this. And then you might page it on that. This is your average. This is taking all the numbers and averaging them. The thing about this, though, is it moves more slowly. You have a lot of requests. Some of them can be way out there, 5 seconds, 10 seconds, et cetera. You probably don't care about those, so you take the average. That's going to move very slowly, just with the peak of your latency. Or you could look at 95th percentile, which moves a lot more quickly. And many SLAs are sort of written at sort of the 95th percentile. It's broadly accepted as sort of the, okay, if you can deliver a certain latency at the 95th percentile, then that's good enough. Because we always know that 1 in 20 requests are just going to be crazy outliers, or they're doing something weird. For paging, often 95th is right. You want to say, okay, let's look at our 95th, and if that's above 300 milliseconds, then we've got a problem. Because, again, that's sort of, 95th means 1 in 20 requests are outside of this. So when you set up that alert, that means 5% of your traffic is failing this metric, and you're ignoring it. So you might look at 99th percentile, the long tail. You say, okay, well, this is a little closer to the end, but it's still ignoring the 1 in 100 requests that are way out there. And you can, but it gets really, really spiky. Like, depending on your traffic workload, if you have enough traffic and the distribution's close enough, that can be fine. At this point, with like 1,000 servers, I don't think it's feasible. I think you need a lot more traffic than a website like that has. You need a lot more than 1,000 QPS to make the 99th be anywhere near reasonable for most. So great. We have end-to-end visibility, new metrics, success. We are done. We're not actually done. Having a lot of data and monitoring it doesn't actually make you able to respond to problems. It doesn't help you that much. You need to be familiar with your data. Don't just watch your graphs when you get paged. You need to actually spend time with your graph every day, look at it in peak, look at it in trough, know how your metrics respond when somebody publishes an article in TechCrunch about your business, or Ellen posts a selfie on Twitter, right? Like, know what everything looks like, know how it responds, and your goal by doing this as an SRE, as somebody in ops, as somebody who cares about this stuff, you should be able to look at a graph and say, this is weird, rather than, is this weird? Because the time you take to think about your data and your graph is time you're not spent fixing the problem. So be familiar with it. This is, again, Ben's talk this morning was great. He mentions practice, he mentions drills, he mentions his sort of wheel of misfortune, things like that. Understand your data, think about it. Another thing you can do with time series that you'll want to start doing is sort of this automated or automatic familiarity. If your time series, once it goes long enough, you can start to ask really interesting things like, page me if traffic today is down more than 10% from last week. Because most of us are in very cyclical traffic patterns. It comes and goes throughout the day. But you're going to have a weekly, like Mondays look like Mondays, except for like holidays and things like that. But broadly speaking, this kind of alerting is very helpful for finding things that your other monitoring misses. Like, there may not be a problem yet, but this is sort of that idea of smell. If you look at traffic and you're 10% down from last week, that could just be ebb and flow of traffic, or it could be, I don't know, your AS has been hijacked in Turkey or something, and you've lost a country, right? Worth investigating. Look at your, use this as sort of ways to go look at the rest of your data and figure things out. So time series are pretty amazing. You can do some really interesting, powerful alerts with them. You can ask really powerful questions. But let's not forget that probably most of these are built off of check-based systems. I think every company I've been at that has a time series still has their old system that has a bunch of checks. And I'm not saying you ever should necessarily get rid of that, but One thing that we don't do enough of is thinking about removing alerts. Things get superseded. We do this with hardware all the time. We're like, the PUE of this hardware is way too low compared to the rest of our hardware. It's more money. It's better for us fiscally to get rid of this hardware, even though it still has useful life, and replace it with new hardware. We do that with hardware. We should do that with alerts. OK, this alert, it served us well for 3 years. We've moved on. Let's get rid of it. Be aggressive. And worst case, you have your umbrella checks. And if it's a good set of umbrella checks, even if you screw up the rest of your alerting, you'll still get paged when the site goes down. So the related sort of meme for this one is, if we don't fix it, why are we monitoring it? So great. We're going to slightly switch gears a little bit here, talk about sort of the company's growing. You have your great check system. You have your time series system. You have lots of alerts. Everything's great. But your team is growing. You have a wide range of skills. A lot of people who are not as familiar with every single component. Your person who helped start the company and now knows all these systems, they can fix things really quickly. But time to recovery is going down overall because you have a lot more people working on stuff. At this point, the processes around your on-call, the things that you do to support sort of your on-call rotations, become really important. One of those is escalation. Nobody should ever be awake at 2 a.m. and go, I don't know what to do. Because the answer is should always be either, I know how to fix this problem, or I know who to call. And the person you call may not know either, but having a defined escalation path really helps. At Dropbox, we have the primary on-call who has a secondary on-call. Secondary falls back to the entire team, which is usually 7 people, and that falls back to the entire organization. So if there's an alert that falls through 4 times, a lot of us wake up. But it makes sure that we always know, and this is sort of in our culture, if you can't fix it, call someone. It's fine. Wake us up. Wake the whole team up. Wake up our head of infrastructure, Akil. Like, it's fine. Like, we would rather have the site be up and the service working than waste 3 hours in the middle of the night because you were afraid to call someone. The goal is to get things fixed quickly. No blame. I strongly believe in no blame. We're all working here. I trust that you're all smart, intelligent people and that you have the best interest of the company at heart and the actions you take are in that vein. So that's great. Related to on-call, handoffs. When you go off-call, breathe a sigh of relief and then write a handoff report. Let me know what happened. Tell me what paged, what didn't, what actions you took, what random hack you had to put in to support this other thing. Pass some information. It's really helpful. Include all pages in action, and put it in email. Searchability is really the key here. It doesn't have to be email, but an email service like Gmail makes it super easy to just, you get paged for a machine, you type in the machine name, and you can say, oh, this was paged for 3 weeks ago, and this thing happened. That's great. Daily pages. This is something I took from Google, but basically it's the idea of testing your alerting system. When you go on call, or every day there's a daily page that basically tests the escalation chain. I mentioned earlier, like we had the watcher, and that tests your monitoring system. That's great. But if your phone's broken, you may never know. This fixes that problem. Because every day at whatever 11 a.m. or local time or whatever your time is, you'll get a page. And then if you're primary, you escalate it to secondary, and secondary might escalate it. And eventually it wraps back around to the primary, and you acknowledge it. And then you've verified that your escalation path works, that you know you can talk to somebody, and that their phone works, and that your phone works, and everybody knows that we're good. It really saves confusion and chaos later. Because at 2 a.m., if I call the secondary and they're not responding, and then I call somebody else and they're not responding, and it's just not a good time. Incident response. As you become larger, this becomes really important. Having an incident response plan. When this happens, this is what we do. And it should be a checklist. You don't want to be having to make complex decisions when the site is down. Humans do not make complex decisions well under pressure, right? Like this is, in aviation, we have checklists. If your engine is on fire, there's a checklist for that. You follow it. And it generally means get on the ground as fast as possible. Literally, you point the airplane down and you exceed 100 knots and stay below whatever 120 knots in the Cessna 172 and land before your engine burns up. Modulo some other shut the engine off, et cetera. So also disaster simulations. Train people. Having a plan is great. Running people through it, through the fire drill, watching them do it is even better. Dropbox has regular DRTs where we will kind of randomly fire off 10 databases have failed and need to be recovered. And we will set up a severity 1 incident response team and go do it. It's all simulated, but it ensures that it works. Again, I mentioned aviate, navigate, communicate. I bring it up again here because in incident response at this scale, you break these roles up. Somebody is technically doing stuff. Somebody is responsible for coordination. Somebody's doing communication, things like that. Breaking up responsibilities is fine. Don't overload whoever's fixing your problem. And again, postmortems are important and blameless. And actually, I kind of want to amend this now because I was in a talk a little bit ago where they said they don't like the word postmortem, they like incident response because they want to highlight things that went well too. And I love that. So I think I'm going to adopt that. So thank you. So we're still growing. MyWebsite.com is a large company. We have SREs, and lots of interested parties. That's great. Systems are now incredibly complex. You're going to be on call for stuff. You're going to get a page, and you're going to go, what is this? I've never heard of this. Just fix it. Like, that's great. So dashboarding, which is basically my sort of philosophy on dashboarding, is you have your top level, which shows your umbrella checks. Those are the basic health markers. Each of those levels dives into details. So you have your top level. It probably says, oh, here are the 7 systems that you are responsible for. This one took a dive. You click that, and it has all the sort of the white box checks and graphs that say, here are the different components and things that make the system up. Here's what's wrong. And right here on the same page, since we're probably using web pages for dashboards, and it supports things like hyperlinks, you can say, here's the documentation, here's who to call, here's your developer on call, here's whatever you want. It really helps the 3 a.m. problem where your brain's fuzzy, and you're like, oh, I know I saw the docs for that on the wiki somewhere, and you have to go to the wiki and look things up, and like maybe you find the right docs, maybe you don't. Wiki search is terrible, difficult. Related to this though, be familiar with your data. Watch it, look at it. Another thing that starts to creep up in sort of larger organizations is this sort of idea of tossing things over the wall, or, there should be no wall. There should be coordination. You have software engineers, SREs, we should work together. We're on the same team. We're supporting the same company. If the stock goes up, my stock price goes up, and so does yours. So let's work together. And if you work for a nonprofit, you do better by being faster and better. So our incentives are aligned to cooperate here. And really, one thing I strongly believe, different backgrounds bring diversity of viewpoint. And this applies to software engineers and SREs, but this also applies to people of different levels of experience. If you have junior folks, they bring fresh eyes. Listen to them. If you have senior folks, they've done it before. If they tell you this is probably going to fail, they might have a point. They might not. Dropbox specifically has software engineers and SREs on the same rotations. So when I go off call, well, I go off call to another SRE, but she goes off call to a software engineer, right? We just hand it back and forth. Another sort of thing that becomes important as you have grown is you don't want to be this guy. He may be suave and sassy, but he didn't monitor the servers. Automate your automation. Computers are very good at automation. You can program your monitoring system, your time series system, your check system, whatever, to just, when a new machine comes up and it pixie boots, comes into the network, whatever your machine onboarding process is, Puppet runs a bunch of stuff or Chef runs a bunch of stuff, and then it goes, oh, and then I write out the monitoring configuration because it's 2014. I shouldn't have to touch another Nagios config if I'm at a place that has this sort of automation. And if not, I should build it. And monitor by default. Feed the time series. You want that data. You want to be able to, you never want to get paged for something and go, oh, we forgot to monitor that, right? Because, well, now you can't, or now you don't have the data you need to solve the problem quicker. It's hard to read this slide, but basically it's the XKCD automation slide. If you've seen it, that's great. If not, it's the idea of eventually you just spend time developing automation software instead of actually fixing your problems. But I'm going to say, don't fear automation. There's a common sort of problem where somebody's like, okay, 97% of the time, if you get paged for X, the right action is to push this button, and then go watch some graphs. Because sometimes that button does the wrong thing. Or sometimes there's this other weird edge case, and we haven't really fixed it or sussed it out, et cetera. So, we're not going to automate that. I respond very quickly to that is just automate that noise. Just seriously. If the fix is a script, It should be automated. My argument for this, think about it. You get paged at 3 a.m. You wake up. What do? Well, if you're familiar with the alert, you'll go deal with it. If you're not, you go to the playbook. The playbook, you pull it up, has been well documented by a well-meaning developer who has written 13 paragraphs. Here's this graph and here's this graph. And you look for, because it's 3 a.m., you look for the one step that says SSH to here and run this. You copy, you SSH, you paste, and then you close your laptop and go back to bed, right? So all you did was just push the button, and then you didn't go watch the graphs. I mean, some of us will probably, in our earlier years, in our first couple of years, we might actually stay up until 4 and do this, but eventually you're just like, screw it. I have a good set of umbrella checks. I'll get paged if something goes wrong, if something goes worse. So you should have just avoided the page to begin with and automated the system so that you only get paged when there actually is a problem to go deal with. It all feeds back into itself. I'm running low on time here, so I will have a very brief random assortment of other things that I feel are just important to mention because we don't do them enough. Scrub your raids, for goodness sake. If you have raids, scrub them. Like, kick off a job and then monitor it, because the time you want to be scrubbing your RAID is not when you fail a drive and you put a new drive in, and then it has to rebuild that drive and discovers an error on the other part of your RAID 5. RAID 5 minus 2 drives is, well, goodbye. Restore your backups. Having backups is great. We have lots of backups at Dropbox, and we restore them. You should restore them too. It helps make sure that your backup system is working, that if crap does hit the fan, you know how long it takes to restore things. And you're not just waving your hands going, well, we have to restore this cluster. I think it'll take 3 hours. Like, just restore them, test them. Perform DRT. I think this one's been hit up enough. Keep a low bus factor. If you haven't heard this phrase before, it's the idea of knowledge central to one person. It's highly efficient. If I know everything about a system, I can fix the system very fast. When I go fly to my honeymoon in Maui or something like that, and you get paged for the system, please enjoy. That's not great. You want to keep that low, and that does mean that's a lot of policy and procedure, et cetera. But group accountability, have people cross-train, document things as best you can, do the handoffs, which helps spread knowledge about how to handle things. That's great. A bit for managers, because I think it's important to sort of mention their role in all of this. You're responsible for your team's health, right? You're responsible for keeping an eye on it, for thinking about it, for sort of the systemic issues, right? SREs, software engineers, people who carry pagers and stuff, which most managers don't, but some do. But the people who carry pagers are down in the weeds. I'm getting woken up at 3 a.m., I'm dealing with something, I'm documenting it or whatever, and even if I have best practices, it's hard for me to keep a look at the rest of the systems and other ways I could improve things. A manager's point of view can be really helpful to do that. And that's one of the really big valuable things you can do is say, you know, I think we've been spending too much, like a lot of time on this, and we could probably make it better. And I'll go, oh, you're right. If I wasn't dealing with it, I would have thought of that. So team effort. Also, promote coordination. Generally speaking, like, avoid the up and over, like, have people talk to each other. Like, again, we go back to we're all smart, we're all trying to be good actors here, we're trying to advance our company's interests, our own interests, et cetera. But, like, work together. We're just trying to get things done. And managers are a huge role in this, like, because the manager sets the tone. If the manager starts being like, oh, you know, CC on me on that, loop me in on that, keep me in on that, I want to know that, talk to me about that, et cetera, then it ends up being these sort of groups that don't work too well together because then the managers have to, it's a mess. So brief recap, some random things that are important, that are actually relevant to the rest of the talk and not just random tips. Pages should be actionable. Please, if you page me, let there be something for me to do. Quality of life is very important, right? As you get into larger organizations, as our industry grows more, we have to start thinking about how do we take care of ourselves? How do we build sustainable processes? Like, how do we keep people happy, keep them engaged? We can't just run through them. Like, people are not renewable resources, broadly speaking. Put time into information organization. Like, have this be, like, it's all well and good to release features to hit reliability goals. But if you do sprint planning, if you do whatever sort of, however your method of organizing tasks are, have some percentage of them be information organization, going through wiki pages, making sure they're up to date, making sure that the playbooks are all linked, making sure the dashboards are all looking good. It's all great. Computers are also good at automation. Do it. People are very expensive automation tools. You'll probably get better bang for your buck by having computers do it. Coordinate with each other, be respectful, or be excellent to each other. And so with that, I will say thank you. Again, I'm Mark. Thanks for coming.